Hi all, welcome to i-tutor Academy. In today's session, we will start with MMPC-009, Unit 7, Subsection 5. And in last video, we covered till subsection 4 of MMPC-009, Unit 7. And it's two jobs, M machines case. Okay, in last sessions, we covered two machine cases. This is M machine cases and two jobs are there. Okay, so when there are two jobs each having its own processing sequence on M machines, the optimal sequence of these jobs on the M machine to minimize the total processing time can be obtained by using a graphical procedure as outlined below. And first one is construct a two-dimensional graph where the x-axis represents the processing time and sequences of job 1 on the M machine, while the y-axis represent those of job 2. Okay, and shades the area where a machine would be occupied by two jobs at the same time. The processing of both jobs can be represented by a continuous path which consists of horizontal, vertical and 45-degree diagonal segments. The path starts at the lower left corner and stops at the upper right corner, and while avoiding the shades area in the graph. So in other words, the path is not allowed to pass through shades area which correspond to operating both jobs concurrently on the same machine, since a diagonal segment implies that both jobs are being processed on different machines at the same time. A feasible path that maximizes diagonal movement will minimize the total processing time. The schedule is determined by trial and error. Usually only a few lines may be drawn before an optimal path is found. And example 7.3 is here. So please refer this, and its solution also here on the graph is there. Processing two job on a machines. The graphical representation is there. So please refer your IGNOU study material MMPC-009 Unit 7 and subsection 5. So here also Gantt chart is there. Okay, so two type of charts are there. Next is scheduling rules for job shops. What are the rules? We have seen that the procedures suggest above apply to very simplified situation involving one or two machines or only two jobs. Moreover, the problem treated was one of the static job or flow shop in which all jobs are available at the beginning of the horizon and the schedule once made is not distributed till all the jobs are completed. And unfortunately, even the general static job shop problem of n jobs and m machines with the objective of minimizing the total completion time does not have a general exact solution procedure. There are some heuristic technique used that may obtain good sequences or even optimal sequences, though it may not be possible to check for optimality. And you may, for instance, refer to Campbell, Dudek and Smith and Stinson and Smith for example of such heuristic procedure. And practical job shops are much more complicated and may have hundreds of machining centers and thousands of jobs. In such cases, resort is made to priority dispatching rules for sequencing job at each machine center, and these can apply both in static and dynamic job environment. And in the former case, priority of jobs once assigned are not changed, whereas in the latter cases priorities are updated as job enter or leave the machining center. Some commonly specified priority dispatching rules are here. And select FCFS, that is select the job on first come first served basis, SPT. So please go through this, short forms are there and its explanation also here. And based on simulation studies of various job shops, several researchers have come to certain conclusion about the behavior of these rules. Clearly, such behavior is affected by factors like criteria of performance, level of uncertainty, and job arrival pattern. The SPT rule consistently tended to give the lowest mean flow time even for large shops, a priority that have been demonstrated in the simple n job one machine case. However, with the SPT rule, the varies of flow time tended to be large, and in this regard other rules such as FCFS perform better. A recent survey uh, of dispatching rules for manufacturing job shops operations has been done by Blackstone, Phillips and Hawke. The interested reader may refer to this for the further details of job shop. Okay. And next is problems and the prospects of job production. What are the problems and the prospects of job production? Most of the problems in job production arise from the variety of jobs arriving and demanding individual processing sequences on the scarce facilities in the job shop. And owing to these factors, the job shop is characterized by the following typical problem, that is complicated and unsystematic material flow pattern, and large in-process inventories, large waiting time for jobs, large completion time for job, and unpredictable problem owing to the large variety of tasks. And we have seen that essentially two kind of research pertaining to job shop scheduling has been done. And in the first case, there has been an attempt at developing new procedure for scheduling with a variety of objectives, and we have seen some example of this procedures section 7.3, 4 and 5, right? And most of these procedures have been developed for the static job or flow shop. And clearly, a lot more could be done in this direction. The major difficulty in large job shop is the combinatorial increase in the number of possible sequences. With better bound and more efficient computational facilities, this problem could be probed further. And the second kind of scheduling research has been to test the efficiency of different priority dispatching rule using simulation, and some of these scheduling rules were described in section 7.6, and the advantage of this approach is that dynamic features can be incorporated and evaluated. There are possibly two extremes for scheduling the new job in a dynamic environment: to produce a new schedule each time a new job arrives, or to completely finish the existing schedule before producing a new schedule for the job that had arrived in the meantime. Or a solution between the two extremes could be considered, and ignoring computational consideration, one could have an online computer system whereby every time an operation finishes on machine, this information is fed into the computer. The program then considered the actual status of the shop at that time and all the relevant data, and applies some criterion to select the next operation for that machine. And this approach may be computationally very demanding and economically not feasible, hence less frequent rescheduling and may be done. And what is the right frequency of the scheduling with its implication on cost and effectiveness? This has been an important question for researchers. Some studies in this regard are available in Mohlman, Lockett and Farm. Next is, this is about this unit, and the summary of this unit is here. In this unit we have presented the features of job production, which essentially involve the production of a variety of job in small production quantities with a limited set of facilities. Each job has its unique processing requirement and thus follow its own path through the shop, and the variety of problems that may arise in the job shop have been discussed. Depending on the number of jobs to be scheduled, the number of processing facilities, the type of manufacturing facilities, the manner in which job arrive at the shop, and the criterion for evaluating the effectiveness of a schedule, different procedures can be used to determine the optimal sequence. Some procedures for the n job 1 machine case, n job 2 machine case, and the 2 job m machine case have been discussed with simple illustrative examples. And some priority dispatching rules used in practical job shops have been presented, and comments on simulation studies of job shops have been made. The status of research in job shop scheduling is touched upon, and some hints for probable future direction of work are given. Okay, so this is about the summary, and keyword sections are here. If you feel any words are difficult, you just refer this section. And here is self-assessment questions also here, and around 8 yeah, 9 questions are here. It's based on chart problem solving questions, and also just what is the distinctive feature of job production as compared to mass and batch production system, like that. Simple questions and direct questions also here. Try to do it, it's very important. It will help you for your term and examination, and in between any doubts you can contact us anytime. Thank you so much. For more MBA videos, you just do like, share and subscribe our channel. Thank you.
i-tutor Academy presents IGNU MBA Complete Syllabus Coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.